Merhaba arkadaşlar, hoş geldiniz tekrardan. Çok kısa bir Türkçe bir intro yapacağım önce ama tabii konuşma İngilizce. Yan Choi, benim tabii 10 senedir herhalde görüştüğüm bir arkadaşım. Las Vegas'ta her sene görüşüyoruz kendisiyle de. Sağ olsun bu sene davetimizi kırmadı. Özellikle serverless alanındaysanız mutlaka onun bir blog postunu vesaire okumuşsunuzdur. Sunumun tabii süresine göre sorularınız varsa sunum bittiğinde soru da alabileceğiz. Aklınızda olsun. So Yan Choi is my old friend. You know, we know each other.
Many years
maybe,
now?
I don't know.
Yeah, probably.
Yeah, we see each other every year at AWS Rainment in Las Vegas. So I'm really happy that Yan is here today, and you probably heard his name if you are into serverless somehow. So this is going to be a great talk. Thank you for coming, and keep your questions, and we will you will be able to ask them at the end of the talk. So thank you very much.
Thanks, Ahead. All right, good morning, everyone. Thanks for coming here, and I'm going to share with you some of the money-saving tips that I have learned as my journeys into serverless over the last couple of years. So, quick introduction, my name is Yan Choi. I have been working with AWS, running workloads on AWS for over, I guess, maybe almost 15 years now. And nowadays, I spend half my time working with the Lumigo team to help them advance serverless observability. And the other half of my time, I work as an independent consultant, working with other companies to help them adopt serverless. And I've collected lots of different tips in terms of how to optimize your application for cost efficiency. And I've got 120 slides and 30 minutes to share with you all. So I hope you're ready to drink from the fire hose. So tip number one is this pretty much applies to everybody, that if you're running stuff on AWS, you need to have billing alarms. And I know they're not perfect. They are normally a few hours behind real time, but still it's better to find out that you have a cost-related problem a few hours late than, say, a few days or a few weeks late. And you can really save your bacon when the time comes. And take, for example, the guys from PostNL, they ran into a problem where they had a bug in their code whereby instead of caching the response from Secrets Manager, they were making a call on every single invocation. And so suddenly the cost for Secrets Manager spiked over the course of a couple of days, and they got the alarm telling them, hey, there's a problem. And imagine if they didn't have the alarm, then they would learn about this problem much, much later. Maybe don't notice it for weeks or months at a time until the bill comes and someone comes, hey guys, what are you doing? Why are we getting this massive bill from AWS? So the lesson is that, yes, billing alarms is not perfect, but they can, you should still have them. And when you have a surprise situation, they can definitely save you. What's not a surprise for me nowadays is that monitoring costs, specifically logging costs, is much, much higher than what most people's application is actually cost them, especially in the serverless space. And pretty much every customer's application I look at their bill. CloudWatch is always in the top 3, oftentimes much more than API Gateway and Lambda. And the worst thing is that as you collect more logs, your cost goes up, but the value of those logs actually go down because you have much more noise, much more difficult for you to find the information you actually want. And so here's a couple of tips to help keep your CloudWatch logs cost down. First, you want to start doing some structured logging so that you can put into place information that you're going to find useful to filter them. So, for example, you want to do structured logging with sensible log levels. You don't want to log everything as info. In fact, most of the things you log should be logging as debug. And in production, you don't want to log, you want to raise the log level, the minimum log level, so that you don't get all of these debug logs in CloudWatch. But those debug logs are useful when you do have a problem. So what you do in that case is instead of always getting all the debug logs, you sample them. Say for 1% or 5% of your user requests. That way, you hopefully have enough debug logs to cover all the different code paths. So when there's a problem, you can figure out what the problem is, but you're not paying for all those millions and millions of lines of debug logs that you don't actually need. And last thing is that you want to maybe set your log retention to like 30 days or even 7 days, because chances are, as time goes by, the value of those logs will be going down as well. And in this case, keep in mind that you're not only paying CloudWatch for processing and ingesting logs, but also for storing them as well. By default, CloudWatch retention policy is indefinite, so they don't retire any logs at all, and you don't want to be paying that, like 3 cents per gigabyte for all the logs your application ever produces over time. And many of you listening here today may be using some third-party vendor already for your logging, so that you're collecting the logs from CloudWatch and forwarding them to Logly or whatever, Datadog, what have you. In this case, they also charge you for ingestion and storage of the logs. And since you're also paying CloudWatch for all of that, then there's a good chance that you're double paying for the processing and the storage of those log messages. And again, if you're not getting good value for those logs, then yeah, this is just money going to waste. So nowadays, for serverless applications running on Lambda, a much better way to collect those logs is to use Lambda extensions with the telemetry API, which allows the Lambda extension to poll a local endpoint to get the log events so that they're able to process them, and in this case, send them to the vendor directly. And once you've done that, you can also disable Lambda's permission to talk to CloudWatch logs so that the Lambda is not able to write the log messages to CloudWatch, and therefore, you don't pay for those messages in CloudWatch because you're just sending them straight to the third-party vendor you're using for logging. And in case you're looking for a vendor, you want to move away from CloudWatch, Lumigo has now support for log management, and it's a lot cheaper than CloudWatch as well, so check them out. But if you're staying with CloudWatch and using CloudWatch logs for all of your Lambda functions, you probably have seen those system log messages, right? The start, end reports. And if you're running at any level of scale, you also might find that just those system messages can amount to non-trivial amount of money per month. So nowadays, what you can do to disable that behavior is using Lambda's new advanced logging control, whereby you can set up a new logging config object as part of your deployment. And in there, you set the log format to JSON. And once you've done that, you can then use a system log level to control what information is included in the system logs whenever your Lambda function is invoked. In this case, if you set it to debug, everything's going to come through. But if you set it to warn, then you're not going to get any of those system log messages from Lambda to CloudWatch anymore. But you're still going to get log message whenever there's an unhandled exception in your Lambda function, which is quite useful. And staying with Lambda functions, the main way you can optimize the cost of Lambda functions is to adjust the memory size of your function. Because for Lambda, more memory equals more CPU and more bandwidth, but also more expensive per millisecond of execution time. And so the longer your function runs for, the more expensive it's going to be if it's on a higher memory setting. And the problem with this is that it's just one single setting, and it's really easy to get it wrong by an order of magnitude. You can go from 1 gig to 10 gig with one typo, and suddenly your cost is going to go 10x as well. And this happened to one of my customers who was doing some, I think, video rendering work in Lambda, and they knew that more memory equals more power, and they wanted to get this video processing done very quickly, so they offered a 10 gig maximum. And what they failed to, I guess, account is that once you go over 1.8 gigabyte of memory, you don't have one CPU core anymore. You're going to get multiple CPU core. So at 10 gig, you're going to have 6 CPU core. And to take advantage of that, you have to write your application to take advantage of multi-core. They were using JavaScript, which runs on a single thread event loop. So they weren't using all the CPU cores, and which means most of what they actually spent was being wasted. And so, as Donald Knuth famously said, 97% of the time, we should forget about small efficiencies. And I think this applies to Lambdas as well. Most of the Lambda functions I've ever seen in the wild are running at really low in terms of execution count and also duration, so they're not really going to be a problem. There's no return on investment for optimizing. But you typically find maybe a few percentage of Lambda functions where you do have that high cost because it either runs very often, runs maybe millions of times a day, or runs for a very long time. So in Lumigo, there's a dashboard where you can see all of your functions. You can sort by estimated cost, and you can then very easily identify there's 3% of use cases where you should optimize your Lambda functions by right-sizing the memory setting for those functions. And to do that, there's a couple of ways to do it. The most popular one is to use the Lambda power tuning tool from Alex Casalboni, where you can essentially use a state machine to execute your function across different memory settings. And you can see how the performance changes as you allocate more memory, but also how the cost changes as well. So you can find the sweet spot in terms of, okay, what's the best memory setting that gives me the best performance, at the most reasonable sort of cost. You can also use the compute optimizer as well, which is another way you can find the right memory setting for your function. And one more thing you can do with Lambda is by default, it runs on x86, but you can also run it on ARM instead. And the reason why you want to do that is because on ARM, the execution cost per millisecond is about 25% cheaper than x86. However, the performance of ARM for different workloads is going to vary very, very widely. I've had cases where when I go from x86 to ARM, performance dropped by 60%. So if it's 25% cheaper per millisecond, but I'm running for 60% more, then overall, I'm spending more money on those invocations. And so make sure that you're testing the ARM architecture against your workload before you make this switch. However, ARM is very good for functions where you're spending most of the time just waiting for I/O. Imagine you've got a function that handles a user request and it calls a third-party API. And imagine that third-party API is Salesforce because they're famously slow. So you're spending seconds just waiting for a response. Then why pay for that CPU at a higher rate when you can go and save yourself 25% by just switching to ARM? Another thing you can do is apply clever, efficient caching strategy to your application. To me, caching is almost like a cheat code for building large, scalable, and performant applications, but also cost-efficient one as well. And if you consider a typical, say, serverless API, where you've got Route 53 for custom domain name, CloudFront in front of your API gateway, and Lambda, and then DynamoDB. So in this case, I will always have some client-side caching. And depending on whether you're building with web or mobile, you may get that out of the box. But client-side caching alone is not very efficient because you're doing a full round trip for every single client. So you also want to do some server-side caching. And for about 90–95% of use cases I've seen, the only server-side caching you need is edge caching with CloudFront. And there's some cases where you say, okay, we're doing some heavy computation in our application, and it's not a GET request, so we can't just use CloudFront to cache that. So in that case, you can also do some application-level caching. Your Lambda function is going to do this heavy computation once and save the result in, say, like Elastic Cache, so that the next time you see this request, you can just pull the result out of the cache. But Elastic Cache charges you based on uptime. Even if my application is not running, I have to pay for that cache node. And I don't like that. I want to have pay per use. So that's why nowadays I actually prefer to use Memento Cache instead, which actually gives you a serverless caching that only charges you based on data transfer, not by uptime. And talking about caching, another caching that we don't often think about is Route 53. DNS records are cached by default, but you have to control what TTL or time to live you want to set on your DNS records. And Route 53 charges you based on the number of DNS queries you receive. So at scale, with lots of clients, applications talking to your application, you want to think about using a longer TTL, more than the default thing 5 minutes that you get with Route 53 for stable domains. So domains that you know are not going to change very often. Otherwise, well, you're going to cache it for 5 minutes. The next time someone uses your app, it's going to be DNS all over again, and you're going to pay for that query again. So if you know the domain is going to be stable, just cache it for hours, days, or even weeks if you know it's not going to change very often. Talking about domains, another thing that comes up all the time in terms of problems we run into as web developers is cross-domain requests. One of the ways this manifests in terms of cost is that, well, it's really easy to enable calls for an API gateway. But what you may not realize is that those option requests that you make from the client to API gateway, you still pay for those, right? And you may think, okay, well, those option requests are cached anyway, so what's the problem? The problem is that there's a long-standing bug in API gateway in terms of the option endpoint it generates for you. And if you're doing authenticated APIs, that you need to use the authorization header, unless you set the access control allow headers and include that authorization header, the caching, the access control max age header doesn't actually work. So there's a very good chance that if you look at the client server request you're making right now, you may find that those option requests are not being cached as you may think. So you may be double paying for all of your API requests that are cross-domain. So one way to get around this is to just not have cross-domain at all. If your UI is hosted on example.com, don't put your APIs on a subdomain. Instead, put them on a path on the main domain so you don't have calls at all. Another thing that to think about is when you're architecting on AWS, essentially you're going to a shopping mall. You're picking what services you want to use because in the cloud, every architectural decision you make is a buying decision. And picking the wrong item off the shelf can be very, very expensive. And you always have to consider your workload and your context. So say, for example, I want to process messages. I need something to ingest messages and process them and filter and fan out. Looking at the cost, okay, for a system that runs 1 message per second with 1 kilobyte size payload, Kinesis is super expensive, right? It's order of magnitude more expensive, even though it's just $10. However, if you scale that to a system that runs 1,000 messages per second, suddenly the picture swapped. And now, all the magnitude difference is actually significant in terms of the amount of money we pay. Same happens with APIs. If I'm doing 1 request per second, API gateway, cheaper than ALB, simpler than ALB. Not so much when you're running 1,000 requests per second. Again, this is assuming 1 kilobyte per request you're handling. With ALB, you have to keep in mind that the way you calculate it is based on 4 different dimensions, one of which is the amount of data processed. And general rule of thumb you have on AWS is that services that charge you based on uptime tend to be order of magnitude more efficient once you're running at scale. But throughput is not the only thing you should think about in terms of scale. Now, you think about the same case again. What if your endpoint either receives or returns 1 megabyte per request at 1,000 requests per second? ALB, the way it calculates ACLs, is going to be hugely more expensive compared to anything else we've got here, right here. So always take into account your specific context, not just throughput, but also your data as well, data transfer rate. Another dimension of this conversation about choosing the right service, as Werner points out in the Frugal Architect, where he outlined 7 different laws for a frugal architect to follow. Law number 2 and 3 says that architecture is a series of trade-offs we have to consider, and we should prefer systems whose cost scales with the dimension in which our business revenue grows. So in this case, imagine you're building some application, you need WebSockets. This could be like a social media app, and if you look at what you have available on AWS, API Gateway, AppSync, IoT Core all support WebSockets, and they all charge you based on number of messages you send, but also the connection time. And if your application grows in terms of number of users, connection time is going to keep going as well. But if your business revenue from those users doesn't grow with connection time, but it grows with engagement, how much people actually use the app, not just how long they're connected for, then you want to pick systems that charges you based on activity, not based on connection time. So what can we do in this case for WebSocket application? There's also, again, Memento topics, which gives you a pricing model that's based on pay-per-use. So you only pay for data transfer at $50 cents per gigabyte, and you don't pay for uptime, you don't pay for connection time, and don't pay for messages. So this allows you to have a system whose cost grows with the dimension in which your business revenue grows as well. In terms of architecture, one of the things I love to do is to removing stuff from my architecture, the same way that I like to remove code from my code base. And anytime I want to add something to my architecture, you always want to just think before you do that and ask yourself, does this thing I'm adding add any value? So if you're doing a synchronous call from a Lambda function to another, by the way, pretty much always a bad idea. Instead of doing that, just do whatever you have to do in the first function. Combine them, removing unnecessary moving parts from your architecture. Cheaper, easier, simpler. Synchronous Lambda invocations are pretty much always a bad idea. You don't want to do that. But there are legitimate use cases for asynchronous Lambda to Lambda invocations. So in this case, if I want to invoke some Lambda function asynchronously because I want to offload some work from my user-facing API function to some background thing, I can either put the message in the SNS topic and trigger another function, or I can just call the other function asynchronously without having to have a SNS topic, because all the benefits of having SNS topic is already there with asynchronous invocation from Lambda. You've got DLQs, you've got internal queue that you can use within Lambda's asynchronous invocation, so there's no need for extra moving part in the architecture. Again, anytime you're looking at this, every component in your architecture, you should ask, what's the point of having this thing? Does it add value? What's the return on investment for this extra complexity and component that's going to cost me, because everything I'm doing is a buying decision? And the answer can't be, well, that's how we've always done it, because how we've done it is probably not going to cut it when we need to optimize for specific characteristics, like when we're doing things and we want to optimize for the most cost efficiency, and when you want to optimize for cost, sometimes you have to make moves that may not be palatable or things that people actually are doing normally. For example, you may not want to use API gateway and just go straight from user to Lambda function and exposing the function capability as with function Lambda URLs and writing your function as a Lambda lib and removing API gateway and all the costs associated with API gateway. Again, if you want to optimize for cost, this is quite a useful move. Especially if you're not using some of the features that API gateway gives you, like direct integration with other services or cognito authentication, and or maybe you're running into API gateway limitations, like the fact that it's got, for some reason, 29 seconds, not 30 seconds integration timeout. Or maybe you need to return a large payload, more than 10 megabytes, and you're running into API gateway's limit on that. With Lambda function URL, you can use response streaming to return a bigger payload than that. However, with this, you do have to, again, it's all about trade-offs. You have to write your Lambda functions as a Lambda lib, where you run, say, like web application inside a Lambda function and handle all of your routing, which means you have less granular in terms of access control, but also in terms of metrics and alerts. So if you've got one function that handles every route, you get an alert. You don't know if it's one endpoint having a problem or is it more systemic that affects all of your endpoints. And sometimes the web frameworks you use maybe not designed for Lambda, so it's quite big, quite heavy, so that's going to have a big impact on the cold start performance for your function as well. And typically, I find the function URLs are great for public-facing, so not authenticated APIs, or for internal APIs that just need AWS IAM, because that's the two authentication options you have with Lambda function URL, either nothing or AWS IAM. But turns out you can also have Lambda functions authenticate a user job token against cognito, and it's actually pretty fast. There's not much performance overhead to doing that. So if you do need to have authenticated API and you do want to optimize for cost, then this is still a valid move. What if on the other side of things, my code is really basic, there's not much business logic, it's just CRUD, it's just getting data from database. So we can go the other direction to go, instead of everything just function, we go no functions, we go functionless. In this case, instead of having API gateway calling a Lambda just so we can call DynamoDB with the AWS SDK, let's just remove Lambda from the equation and have API gateway call DynamoDB for us instead. That way, you remove any cold start performance penalties associated with having a Lambda function in your architecture, and you also remove any costs associated with that Lambda function as well. So another way to simplify, save costs by removing components from your architecture. And it's not just for APIs. Once your, say, API endpoint says something in DynamoDB, and you want to turn that into a domain event so other components can react to that, you can use event bridge pipes to capture the data change events from DynamoDB streams and save them into an event bridge bus. Now, DynamoDB gives you data change events, so it tells you item inserted, modified, removed. Those are not domain events. We don't speak that domain language as part of our domain, so we want to convert that into a domain event so we can use the Lambda function to transform the data to turn it into the right shape for our domain language. And this falls in line with the general philosophy that you should use Lambda functions to transform data, not to transport data. If all you're doing in your Lambda function is to use the AWS SDK, then again, what is the added value from having that function in your architecture? There is none. don't use it. Use Lambda functions where you can actually add value with that function. Same goes to if I want to say synchronize my data from DynamoDB to OpenSearch. Instead of doing DynamoDB stream Lambda write to OpenSearch, just use the no-code ETL these days. Confusingly, not the same as event bridge pipes, but a separate thing. But you can again don't have to write any code, just configure the synchronization for you automatically. Same move can be applied to things that are not REST APIs. You can build GraphQL APIs using AppSync without having to write any Lambda functions, or you can build business workflows with state machines in step functions, and again, step functions can call different services on your behalf. I want to stress this once again, that every component in your architecture should serve a purpose. It must serve a purpose. If it doesn't bring any extra value, then you shouldn't have it in the first place. And always consider the return on investment. And one last move, this is more of a high-level move that I don't think applies to most people, is if we push this idea that everything in our architecture should serve a purpose, then we can push even further to say, okay, what if all we're doing with our API and our Lambda function is to allow the front end to talk to a DynamoDB table, and all we're doing is CRUD, and all we're doing is providing authentication with API gateway and AWS SDK call with the Lambda function, then we can actually have the client talk to DynamoDB directly, and we can do it safely by having the user log in to Cognito user pool, so you get a job token. And then we can exchange that job token into a temporary AWS credentials with the identity pool, which the front end then allows the front end to talk to DynamoDB directly. And we can be sure that this user can only fetch his or her data, because in the configuration for the IAM role that we generate the token with, we can say only add a condition that only allows the holder of this temporary AWS set of credentials to access his or her own data based on the Cognito sub for the user. So a user logging to the front end can only access their own data and can't access anyone else's data. As you can see, this is a pretty high-level move and something that has got a lot of room for you to get it wrong. So it's not something that is, I think most of you will ever need to use. But again, if you want to push the idea to the extreme, how can I build the most cost-efficient architecture that is the most cost, that does exactly what we need with the least number of moving parts? There's way more reason for why you wouldn't want to do that, which I wrote about in more detail in a blog post. You can go read afterwards. But again, it's about, okay, thinking about your architecture, thinking everything in terms of return on investment, and if you need to optimize for cost, what is the extreme we can go to? So those are the 11 ideas, 11 tips for you to consider to be more cost efficient in your serverless architecture. To recap, always have billing alarms. Look for ways to keep your costs down in terms of logging and right-size Lambda functions where it's applicable. Apply caching. Look at your Route 53 TTL. Avoid calls if you can. And then look at your architecture and make sure when you go into AWS, you pick the right services for your workload. I've got a workshop coming up, so feel free to check it out. But otherwise, thank you guys very much. I don't know if you've got time, but go on.
We can have a few
Okay.
questions. We don't have much time.
Okay, maybe one question if anyone have it.
Do you have anyone have a question?
Hi.
Hello. I would like to ask that, like, what is, how to prevent like DDoS attacks for Lambda functions, because it may cost a lot.
So what's that? How to?
DDoS protection.
DDoS protection against Lambda functions. Okay, so you don't do DDoS against the Lambda function directly. If you've got API gateway in front of it, you can use WAF with API gateway. So that way, your Lambda function is not publicly accessible. So you can use WAF to do some DDoS protection. But WAF is only, you can use a rate-based rule, but it's only up to a certain point you can do that. But you can, with API gateway, you still have the sort of endpoint level quota as well. So you can have rate limits on the endpoint for API gateway. For function URL, you have to make sure that you are exposing your function so that with the function URL, also behind CloudFront distribution, and then again attach a WAF against that. But there's no, with that, there's no, there's only rate-based limit, but there's no like throughput-based limit. But you can do that on the Lambda function itself, so that your Lambda function, you can set the maximum concurrency with the reserved concurrency. So depending on whether or not you are using API gateway or function URL, there are two different ways to do that. And both involve using WAF for the rate-based and IT-based rate limit, and then the just global throughput-based limit.
Thanks.
Okay. All right. Thank you so much.
Thank you.
Oh. Okay. Okay. Okay. Thank you.
Thank you.
Okay. Thank you very much.